Welcome to this chapter on reactjs hooks. Hooks are a powerful feature that allow you to manage state, side effects, and life cycles in functional components, without needing to write classes. First introduced in React 16.8, hooks have since evolved significantly. Now, with React version 19.1, they're more stable, more powerful, and even more central to how we build modern React applications. Here is a comprehensive list of all reactjs hooks, including the standard ones up to React 19. With descriptions and use cases. 1. Use state. Description. Add state to functional components. When to use. Used when you need to manage and update state in functional components. 2. Use effect description. Perform side effects in functional components. It replaces lifecycle methods like component did mount, component did update, and component will unmount. When to use. When you need to run code in response to changes in state or props, or to handle side effects such as data fetching. Use context description. Allows you to subscribe to React context without needing to use a context consumer component. When to use. When you need to access context values directly inside a functional component. 4. Use reducer description. An alternative to use state used for more complex state logic. When to use. When managing state that depends on previous state values or involves more complex transitions, for example, handling multiple actions. 5. Use callback description. Returns a memoized version of a callback function that only changes if one of its dependencies has changed. When to use. When passing functions as props to child components that may trigger unnecessary re-renders. 6. Use memo description. Memoizes a computed value, recomputing it only when its dependencies change. When to use. To optimize performance for expensive calculations or operations. 7. Use ref description. Returns a mutable object that persists for the lifetime of the component. Useful for referencing DOM elements or storing mutable values without triggering re-renders. When to use. When you need to persist values across renders without causing re-renders or for direct DOM manipulation. 8. Use imperative handle description. Customizes the instance value that is exposed when using ref in parent components. When to use. When you want to control what methods or properties are accessible to parent components through a ref 9. Use layout effect description. Similar to use effect, but it runs synchronously after all DOM mutations. When to use. When you need to perform side effects that read or modify the DOM before the browser paints, such as measuring layout or performing animations. 10. Use debug value description. Displays a label for custom hooks in React Dev Tools for debugging purposes. When to use. For custom hooks that you want to provide more useful debugging information in React Dev Tools. 11. Use transition. React 18 description. Allows you to mark certain updates as non-urgent, enabling React to keep the UI responsive during large updates. When to use. When you want to manage UI responsiveness during complex updates, such as when rendering large lists or performing expensive calculations. 12. Use deferred value. React 18 description. Lets you defer a value to prevent blocking updates from happening synchronously. When to use. When you want to delay rendering a value, such as in high latency situations, for example, slow network requests or large datasets. 13. Use action state. React 19 description. Used to handle asynchronous form submissions, including states for pending, success, and error. When to use. Ideal for form submissions where you need to manage different states, loading, success, error. 14. Use form status. React 19 description. Provides real-time form submission status, such as pending or the type of HTTP request being made. When to use. Used to show form submission status indicators, for example, loading, success, error. 15. Use optimistic. React 19 description. Handles optimistic UI updates by immediately updating the UI before a server response. When to use. Used for situations where immediate feedback is needed, such as optimistic rendering of data changes before confirmation from the server. 16. Use. React 19 description. Allows components to directly await promises and handle asynchronous operations seamlessly within the render cycle. When to use. When you want to handle asynchronous operations declaratively in your components, for example, data fetching, async operations. When to use each hook. State and effect hooks. Use state. Use effect. Use reducer. Use these for managing state, side effects, or complex state transitions in your components. Performance optimization. Use memo. Use callback. Use transition. Use these to optimize rendering, prevent unnecessary re-renders, or prioritize updates in large applications. Context management. Use context. Use this to access global state or shared data across components. Refs and DOM manipulation. Use ref. Use imperative handle. Use these for direct DOM access or managing references in a component. Debugging. Use debug value. Use for debugging custom hooks and showing useful labels in the React Dev tools. Advanced state handling. Use optimistic. Use action state. Use form status. Use these when managing asynchronous data, forms, or UI updates with real-time feedback. These hooks give you greater control over state, side effects, and UI performance, making React functional components more powerful and flexible. Let's begin with use state. This fundamental hook allows your component to hold and update state. You initialize it with a value and receive back a state variable along with a function to change it. For example, const count set count equals use state 0 gives you a clean, intuitive way to manage local state. Then there's use effect. It lets you perform side effects in your component, things like fetching data, setting up a subscription, or manually interacting with the DOM. React 19.1 continues to optimize how useEffect behaves during rendering and hydration, especially with server components. For accessing shared values across your app, useContext remains the go-to solution. It lets you consume context directly without drilling props through multiple layers. React 19.1 also enhances context handling for better performance with concurrent rendering. Now, useRef is invaluable when you need a persistent reference to a DOM element or a mutable value that shouldn't trigger a re-render. The object it returns survives re-renders and helps with accessing elements, measuring layout, or storing instance values. To improve performance when dealing with expensive computations, use Memo as your tool. It memoizes values so that recalculations only happen when necessary. Paired with useCallback, which memoizes functions, you get smoother performance and fewer unnecessary re-renders, especially when passing handlers to child components. When you need more structured or complex state logic, useReducer is a solid alternative to useState. It's especially useful when your next state depends on the previous one, or when you're handling many state transitions in one component. React 19.1 continues support for useLayoutEffect, which works like useEffect but fires synchronously after the DOM has been updated. It's ideal for measuring layout or performing reads before the browser paints. For situations where you want to delay less important updates to keep the interface responsive, useDeferredValue is helpful. It tells React to give priority to more urgent updates, like user input. UseTransition enhances this concept by letting you define which updates can be interrupted. This is great for scenarios like typing in a search bar while loading suggestions in the background. React 19.1 includes improved scheduling features, making transitions even smoother. When creating components that expose methods via refs, useImperativeHandle allows you to control what's accessible. This is commonly used in custom input components or libraries like modals and carousels. The useId hook continues to shine in React 19.1, especially for generating consistent unique IDs in both server and client environments. It helps avoid hydration mismatches and is essential in accessibility-related markup like labeling inputs. UseSyncExternalStore is another key hook, introduced to work seamlessly with concurrent features. It enables safe, consistent subscriptions to external data stores like Redux or ZooStand, helping keep the UI in sync. React 19.1 also maintains support for useInsertionEffect. This hook is used mostly by styling libraries to inject styles into the DOM before any rendering occurs. It prevents flickering and ensures styles are available before content loads. UseDebugValue lets you label and track custom hooks within React Dev tools. It's mostly for development purposes, but it provides clearer insights when debugging or building shared hook libraries. With React 19.1, useErrorBoundary continues to be refined. This hook helps you programmatically reset or catch errors, which is especially useful when integrating with error boundaries in app frameworks. Finally, there's useEvent, a relatively new addition that lets you define stable event callbacks that don't change on every render. It keeps your app performant and eliminates the need to resubscribe listeners. Now that we've introduced the core hooks in React 19.1, let's look at how they're used in real-world projects. These examples are meant to be simple but realistic, things you might actually build in a modern React app. Let's start with useState. Imagine you're building a to-do list. You need a way to track the list of tasks and update them when the user adds or removes one. With useState, you could write const tasks set tasks equals useState, and then update it with set tasks new task when a new task is added. It's a straightforward way to manage dynamic lists in the UI. Now take useEffect. A perfect example is fetching data when a page loads. Let's say you're building a weather app. When the component mounts, you want to fetch the forecast from an API. You'd use useEffect with a fetch call inside. UseEffect equals greater than fetch weather. That empty array tells React to only run the fetch once, like component did mount. Then there's useContext. Say you have an authentication system and you want all components to know whether the user is logged in. You wrap your app in an auth provider, and inside any component, you can just call use context auth context to get access to the user's status, name, or roles. No more passing props through every level of your app. Use ref comes in handy when you want to manage focus. For instance, after a form loads, you want the cursor to be placed inside the first input box automatically. With useRef, you create a reference to that input, and then use ref.current.focus inside a use effect. It's subtle, but it improves user experience. With useMemo, imagine you're building a product filter in an e-commerce app. Every time a filter changes, you calculate a large list of filtered products. If your original product list hasn't changed, you don't want to refilter again and again. With useMemo, you wrap that filter function and tell React to only recalculate it when the inputs actually change. Similarly, use callback helps when you pass functions down to components that only need to re-render if the function really changes. For example, a child component may re-render unnecessarily unless you memoize the callback you pass it. This is especially important in long lists, where performance matters. Use reducer is great in something like a shopping cart. You need to handle different actions, adding items, removing them, clearing the cart. With useReducer, you define your cart logic in a reducer function and dispatch actions like dispatch type, add, item. It's structured and predictable, perfect for larger applications. For use layout effect, imagine a tooltip that should align itself based on the size of the button it's attached to. You need to measure the button's dimensions before rendering the tooltip. This is a job for use layout effect, which runs before the screen is painted, so there's no flicker. Use transition fits well in live search components. If someone types a query, you might update the UI immediately with their keystroke, but load the results in the background. You wrap the result loading in a transition, so it doesn't block typing or cause a laggy experience. Use deferred value works similarly. If you're displaying a complex chart or grid based on user input, use deferred value lets the immediate input feel smooth while delaying the heavier rendering tasks. In custom components like modals or date pickers, use imperative handle helps when the parent needs to control the child. For instance, a parent button might want to open or close a modal by calling modal ref.current.open. With use imperative handle, you expose just the parts of the modal you want to be accessible externally. When rendering lists or form inputs, use id ensures each element gets a unique and consistent ID, especially across server-side and client-side rendering. This is important for accessibility, so screen readers and form labels link properly. In apps using external state libraries like Redux, use sync external store keeps your React UI reliably in sync with the external state, even in concurrent mode. It prevents glitches or mismatches that can happen when state updates aren't properly tracked. Use insertion effect is more behind the scenes. It's used by styling libraries like Emotion or styled components to inject styles into the DOM before anything renders, ensuring consistent layout and no flashes of unstyled content. When you're building shared hooks across teams or projects, use debug value helps you label internal state for visibility in React Dev tools. You might add use debug value user.name to a custom use auth hook, so others can instantly see what's happening inside. For applications that support recovery or user-based error reporting, use error boundary lets you manually catch and reset errors from within your components. This is helpful for retry buttons, or restoring parts of the UI without a full refresh. And finally, with use event, you can define event handlers, like on click or on key down, that don't change every render, preventing unnecessary re-registrations and re-renders. It's a subtle optimization that adds up in big applications. Welcome to this section of the audiobook, where we explore some of the built-in components provided by reactjs. These components aren't your usual visual building blocks like buttons or cards. Instead, they offer structure, diagnostics, and performance tools that enhance your application's development and user experience. Let's begin with Fragment. In React, every component must return a single parent element, but sometimes you don't want to add an unnecessary wrapper like a div to your markup. That's where Fragment comes in. It allows you to group multiple JSX elements together without adding extra nodes to the DOM. You can write it as fragment or simply with a shorthand syntax using angle brackets, like this. Less than, greater than. This is incredibly useful when returning a list of sibling elements while keeping your DOM clean and semantically correct. Next is Profiler. If you've ever wanted to understand how your React components are performing, the Profiler component gives you a way to do that. It measures how often components render and how long those renders take. This data can be invaluable when optimizing performance, especially in large or complex apps. You wrap the profiler around parts of your component tree, provide a callback, and React gives you metrics about what rendered, when it rendered, and how long it took. Another important built-in component is Suspense. Suspense allows you to display a fallback, such as a spinner or a placeholder, while waiting for child components to finish loading. This is particularly useful when working with code splitting and lazy loading. For instance, if a part of your app is being dynamically imported, Suspense can show a loading message until that part is ready. This improves perceived performance and creates a smoother user experience. Finally, there's Strict Mode. This is a tool for highlighting potential problems in your application during development. When you wrap components in strict mode, React enables additional checks and warnings for things like deprecated lifecycle methods or side effects that aren't handled correctly. It doesn't render anything visible in the UI, nor does it affect the production build. But during development, it helps you catch bugs early and encourages best practices. In the world of React development, there are two main ways to define components: functional components and class components. While both approaches ultimately produce the same user interface, they differ in how they're written, how they manage state, and how they handle lifecycle methods. Class components were the original way to write components when React first became popular. They're built using JavaScript classes and must extend React.component. Within the class, you define a render method that returns the JSX for your component. If your component needs to track local state or respond to lifecycle events, like mounting, updating, or unmounting, you use special class methods such as component didMount, component didUpdate, and component will unmount. State is managed using this .state, and updates are made with this .setState. One thing to keep in mind is that class components require you to bind methods when passing them around, since this can be a bit tricky in JavaScript. Functional components, on the other hand, are simpler and more concise. They're written as plain JavaScript functions that return JSX. Originally, they were stateless and purely presentational, but everything changed with the introduction of React hooks. With hooks like useState and useEffect, functional components can now manage state, handle side effects, and tap into the full lifecycle capabilities, making them just as powerful as class components. In fact, since React 16.8, functional components have become the standard way to build modern React apps. React's own team encourages developers to favor functional components. They result in cleaner, more readable code, and they work more naturally with React's modern features like concurrent rendering, suspense, and server components. They're also easier to test and reuse, especially when creating custom hooks. While class components are still supported and work perfectly well, most new codebases today are written almost entirely using functional components. They represent the future of React development and align better with how the React framework is evolving. So whether you're maintaining legacy code or starting fresh, it's important to understand both paradigms. But for most new projects, writing your components as functions, with hooks, will give you a lighter, more elegant, and more modern React experience. React provides a number of built-in APIs that serve as powerful tools for developers working with modern applications. These APIs give you the building blocks to manage the component lifecycle, handle references, create context, and more. They're typically accessed directly from the React package and are essential for deeper integrations or advanced patterns. Let's start with React.createElement. This is the function React uses under the hood to turn JSX into virtual DOM objects. While you usually write JSX like div hello/div behind the scenes, React compiles that into a call to React.createElement div, null, hello. You might not call it manually very often, but it's the foundation of every component you build. Next, there's React.cloneElement. This API allows you to clone and modify React elements, which is useful when you're working with children passed to a component and want to inject additional props or behavior. For example, a wrapper component might clone a child and pass down a new onClick handler while preserving everything else. React.isValidElement is another handy tool. It lets you check if a given value is a valid React element. This comes in useful when writing utility functions or libraries, ensuring that something passed in can actually be rendered by React. Then we have React.children, which is a collection of utilities for dealing with a children prop. You can map over children, count them, filter them, or convert them into an array. This is especially useful when building reusable components like lists, tabs, or sliders where you need to work with child elements programmatically. Another critical API is React.forwardRef. It allows a component to forward its ref to a child component. This is important when you're building library components like input fields or buttons and want to give the parent component access to the underlying DOM element. React also includes React.lazy, which lets you load components lazily through code splitting. Combined with Suspense, you can dynamically import parts of your app only when needed, reducing the initial load time and improving performance. With React.memo, you can optimize functional components by memoizing them. This prevents unnecessary re-renders when props haven't changed, helping improve performance in complex interfaces with frequent updates. For context management, React.createContext allows you to define a context and its provider. This is a way to pass data deeply through your component tree without manually passing props at every level. It's commonly used for things like theming, user authentication, or app-wide settings. React also includes development focus tools like react.version, which lets you check the current version of React at runtime, and react.strict mode, which helps catch problems early in development by enabling extra checks and warnings. Together, these built-in APIs give you low-level control and flexibility for building advanced patterns, performance optimizations, and scalable app structures. They're an essential part of mastering React beyond the basics and provide the tools needed to build robust, high-quality applications. In reactjs 19.1, beyond the core hooks like useState and useEffect, there's a special category of hooks called the React DOM hooks. These are hooks that interact more directly with the document object model, the actual elements rendered in the browser. They're useful for scenarios where you need fine-grained control over rendering behavior, focus, measurements, or event handling. These hooks aren't just about logic or state, they're about the physical representation of your component in the browser environment. One of the most commonly used DOM hooks is useRef. While it's often associated with storing mutable values across renders, it also gives you a direct reference to a DOM element. This allows you to perform imperative actions like setting focus on an input field, scrolling to a certain section, or interacting with a canvas or video element. It bridges the gap between React's declarative world and the imperative control sometimes needed in the DOM. Another important DOM-related hook is useLayoutEffect. It's similar to useEffect, but it runs synchronously after all DOM mutations. That means it executes before the browser paints the screen, giving you a chance to measure layout or adjust styles without causing visible flickers. It's ideal for measuring dimensions, computing positioning, or ensuring animations start at the right time. In React 19.1, useInsertionEffect is also available for advanced styling use cases. This hook is called even earlier than useLayoutEffect, allowing libraries like emotion or styled components to inject styles into the DOM before any layout calculations take place. This prevents unstyled flashes and ensures layout accuracy before rendering starts. Another critical hook for interacting with the DOM is useID. This one helps generate unique IDs that are stable across both server-side and client-side rendering. In situations where form labels, ARIA attributes, or list items require consistent IDs, useID guarantees the integrity of the HTML structure. It ensures accessibility features work reliably and prevents potential mismatches during hydration in server-rendered apps. React 19.1 also includes useEvent, a relatively new addition that simplifies working with event handlers. Normally, when you pass a function as an event handler in React, that function might get recreated every render, but with useEvent, you can define stable event callbacks that stay consistent across renders, improving performance and preventing unnecessary re-registrations of event listeners. It's especially useful in large, interactive UIs like editors or drag-and-drop interfaces. Lastly, React offers useSync External Store, which is technically not limited to the DOM, but is highly relevant for keeping UI in sync with external sources, such as browser storage, global state libraries, or even custom DOM-based systems. It ensures your component updates only when needed, keeping the interface responsive and performant. In React 19.1, a new hook called useFormStatus brings a more declarative and powerful way to manage the state of forms, especially when using React Server components and progressive enhancement features. The useFormStatus hook allows a component nested inside a form to access the status of that form submission. This includes whether the form is currently being submitted, whether there's been a success or error, and whether the form is in a pending state. This is a major step forward from manually managing loading states with local component state, because useFormStatus is tightly integrated into the life cycle of the form itself. When used inside a form, useFormStatus lets you build dynamic interfaces that react to the form's current behavior. For example, you can show a loading spinner on the Submit button while the form is processing, disable form controls to prevent duplicate submissions, or update a confirmation message once the submission completes successfully. Since the hook automatically tracks the state of the surrounding form, you don't need to wire up additional props or state variables. Everything happens naturally within the form scope. What makes useFormStatus even more valuable is that it aligns perfectly with React's move toward declarative and server-driven UI. In the context of server actions, it works seamlessly to reflect what's happening with form submissions, even if the form is submitted from a server component or enhanced with client-side behavior. Using it is straightforward. Inside your form, you might have a custom Submit button component. Inside that component, you call useFormStatus. React gives you access to flags like pending, which tells you if the form is in the process of submitting. This allows the button to change its label from submit to submitting automatically, without managing local state. The simplicity and clarity of this pattern greatly improves code readability and reduces the chance of bugs from improperly synchronized form states. Ultimately, useFormStatus is a quiet but powerful addition to React's hook ecosystem. It improves the developer experience by letting you express UI behavior directly based on what the form is doing. Instead of managing everything manually, React takes care of the coordination for you, leaving your components focused, predictable, and easy to maintain. As forms continue to play a central role in web applications, whether for login pages, feedback forms, or checkout flows, having a hook like useFormStatus ensures you can build responsive, user-friendly interactions that feel fast and modern, even when they rely on server actions or asynchronous logic. APIs. These APIs can be imported from your components. They are rarely used. Create Portal lets you render child components in a different part of the DOM tree. FlushSync lets you force React to flush a state update and update the DOM synchronously. Resource Preloading APIs. These APIs can be used to make apps faster by preloading resources such as scripts, style sheets, and fonts as soon as you know you need them. For example, before navigating to another page where the resources will be used. React-based frameworks frequently handle resource loading for you, so you might not have to call these APIs yourself. Consult your framework's documentation for details. Prefetch Addons lets you prefetch the IP address of a DNS domain name that you expect to connect to. Preconnect lets you connect to a server you expect to request resources from, even if you don't know what resources you'll need yet. Preload lets you fetch a style sheet, font, image, or external script that you expect to use. Preload module lets you fetch an ESM module that you expect to use. Preinit lets you fetch and evaluate an external script or fetch and insert a style sheet. Preinit module lets you fetch and evaluate an ESM module. React 19.1 introduces powerful client APIs that are essential when you're initializing a React app in the browser. Two of the most important among them are Create Root and Hydrate Root. These are foundational tools for starting up your user interface and managing how React takes control of the DOM. Let's begin with Create Root. This is the modern way to tell React to render your application into a specific DOM element. In earlier versions of React, the React DOM.render method was commonly used, but that's now considered legacy. With Create Root, React sets up the application using its concurrent rendering engine, which enables more responsive updates, better scheduling, and smooth transitions. You provide a DOM element, like a div with an id of root, and call Create Root to bind React's rendering logic to that container. Then, you call the render method on the root to mount your app. On the other hand, there's Hydrate Root, which comes into play when using server-side rendering. When a server sends a fully rendered HTML page to the browser, Hydrate Root is how React takes over and adds interactivity to that pre-rendered content. It matches up the HTML already in the DOM with the corresponding React components, preserving the server-rendered structure and enhancing it with JavaScript behavior like event handling and state updates. This process is called hydration, and it's a key part of fast, SEO-friendly applications that feel instant when they load. What sets Hydrate Root apart is its tight integration with React's streaming server rendering model. This means React can hydrate in chunks, letting parts of the page become interactive as soon as they're ready, rather than waiting for the entire page to load. This fine-grained control improves performance and user experience, especially on slower networks or complex applications. Both Create Root and Hydrate Root are critical for bootstrapping your app. Whether you're building a client-only React app or a hybrid app with server-rendered content, these APIs provide the necessary hooks to initialize rendering in the most efficient and modern way possible. They also form the foundation for features like concurrent rendering, suspense, and server components. React 19.1 continues to invest in these client-side foundations, making startup faster, hydration smarter, and interactivity smoother. As React apps grow more complex and performance becomes even more crucial, these APIs ensure developers have the right tools to start their apps the right way. When we talk about rendering React on the server, we're stepping into a powerful part of the React ecosystem that allows for faster initial page loads, improved SEO, and better user experience, especially on slower devices or networks. React Server DOM APIs are the tools that make this possible. In traditional client-side rendering, the browser downloads JavaScript, React takes over, and then renders everything. But server rendering flips this around. The server generates the HTML for a component or a full page and sends it to the client. The user sees something almost immediately, and React later hydrates it to add interactivity. This approach is made possible through React server-side rendering APIs. React 19.1 brings enhancements to this model through a more modern and modular set of server rendering APIs. At the heart of it is Render to Pipeable Stream, a powerful API that allows React to stream HTML content from the server to the browser as it's being generated. Instead of waiting for the entire React tree to finish rendering before sending it to the user, React starts streaming parts of the page as soon as they're ready. This streaming behavior leads to faster time to first byte and better user experience. For environments like Node.js, Render to pipeable stream works perfectly with HTTP streams. You initiate the stream, handle when the shell is ready to send, and when all content has been sent. This gives you granular control over how and when to deliver different parts of the HTML. And this becomes even more powerful with features like React Suspense and server components. React also includes a lighter, promise-based version called Render to Readable Stream, which is designed for web-native environments like Dino, Cloudflare Workers, and other edge runtimes. It uses the standard WebStream interface, making it compatible with modern edge and serverless platforms that focus on speed and scalability. Alongside these streaming APIs, React supports Render to Static Markup, a simpler API that renders a component to static HTML without any React-specific data. It's useful when you don't need interactivity, like for emails or static site generation. In React 19.1, server rendering works hand-in-hand with server components. These are components that run only on the server and are never sent to the client as JavaScript. They let you fetch data, compose UI, and even call server-side logic directly within the component itself. This keeps your bundle size smaller and improves performance dramatically. And the server DOM APIs are the backbone that make this possible. What's unique about this modern approach is how deeply React integrates rendering, streaming, and data fetching into one seamless system. Whether you're building a high-performance marketing site, a fast e-commerce experience, or an advanced dashboard, React Server DOM APIs in version 19.1 give you the flexibility to render just the right amount of UI at just the right time. They turn your server into a rendering engine, not just for markup, but for logic, data, and interactivity. And with smarter hydration through Hydrate Root and the ability to stream HTML in parts, React makes the server feel like a natural extension of your component architecture. reactjs has always been about components. But with React 19.1, the concept of server components transforms the way we build applications. It's not just about where the code runs, it's about how you split responsibility between the client and the server in a way that improves performance, scalability, and simplicity. Server components are components that run exclusively on the server. Unlike traditional components that are bundled and sent to the client as JavaScript, server components are never shipped to the browser. This makes them incredibly lightweight from the user's perspective because the logic stays on the server, reducing the amount of JavaScript the client needs to load and execute. You can think of them as React components that generate HTML on the server, possibly including data fetching, file system access, or back-end communication, all without the overhead of client-side bundling. In practice, a server component might be used to render a list of products pulled from a database. Because it runs on the server, it can talk directly to your database or APIs without extra HTTP calls from the browser. And when it's time to render, React sends the ready-to-use HTML directly to the user. The experience feels instant, and your app gets faster because you've skipped the need for extra client-side code just to retrieve and render that data. Now paired with server components is another feature called server functions. These are functions that you can invoke directly from your components, but instead of running in the browser, they execute on the server. It's a new model that eliminates the need for custom API endpoints or separate server logic. You can write a function, like one that saves a form or updates a database record, and call it as if it were a normal function inside your component. React handles the network request and serialization behind the scenes. This model is both powerful and safe. Server functions can handle authentication, access secure data, and even perform complex operations, all without exposing implementation details to the client. It simplifies full-stack development by blurring the line between front-end and back-end, allowing you to write secure server-side logic in the same file where you describe your UI. Together, server components and server functions unlock a new architecture for building web apps. They let you keep critical logic on the server, reduce client bundle sizes, and deliver faster, more responsive interfaces. You don't have to reinvent patterns or jump between different stacks. Everything works in a unified way, directly in React. With React 19.1, these features are stable, well integrated with suspense and streaming, and designed to work seamlessly with modern hosting environments like Vercel, Netlify, and serverless platforms. You can build apps that load almost instantly, use minimal JavaScript on the client, and still offer dynamic, personalized, data-rich experiences. As React continues to evolve, this approach, mixing client and server components based on need, feels less like splitting an app into layers, and more like composing a complete UI, intelligently distributed across the network. It's the future of full-stack development, and it's happening right now in React 19.1. In reactjs, the concept of directives isn't as prominently labeled as it is in frameworks like Angular or Vue. But with the latest versions of React, especially React 19.1, the idea of directives is becoming more formalized, offering developers a new way to influence rendering behavior and interactions declaratively within JSX. So what are directives in the world of React? At their core, directives are special markers or functions that tell React how to behave during the rendering process. They're not components, and they're not traditional hooks. They're lower-level instructions, essentially hints, that integrate tightly with React server rendering, resource management, and optimization systems. In React 19.1, these directives are primarily used with server components and resource loading. For example, directives like useClient and useServer tell React explicitly where a file or a component should execute. If you write useClient at the top of a file, you're telling React to treat everything inside that module as a client component, meaning it will be shipped to the browser and run there. On the other hand, useServer marks it as a server component, which will never be sent to the browser. These directives help React split the app cleanly and optimize which code is loaded where. There are also new directives used for form interactions and async behavior, such as useFormState and useFormStatus. These aren't traditional directives in syntax, but they behave similarly, injecting contextual behavior into your components. For instance, when using server actions, you can attach a server function directly to a forms action attribute. React then takes care of serializing the input and calling that function on the server. Under the hood, directives help manage this flow, keeping track of status, triggering updates, and even resetting fields based on interaction. What makes React's take on directives so unique is how seamlessly they blend into the JSX and component model. They aren't separate tags or templates. Instead, they feel like natural extensions of the component system, allowing you to declare behaviors while still writing in plain JavaScript. In the near future, React's directive model is likely to grow. It'll support more ways to preload resources, inject logic at compile time, or coordinate between client and server components. But even now, in React 19.1, directives already play a key role in controlling where and how your code runs, giving you fine-grained control with a very minimal syntax. So while you might not see a file full of directive tags, React is quietly introducing a powerful system of embedded instructions that are shaping how apps render, perform, and respond across environments. Rules of hooks. Hooks are defined using JavaScript functions, but they represent a special type of reusable UI logic with restrictions on where they can be called. Only call hooks at the top level. Only call hooks from React functions. Rules of React. React is a powerful library that allows developers to build interactive user interfaces with ease, but it comes with a set of rules that are important to follow in order to build maintainable, scalable, and performant applications. These rules help ensure that your React code behaves as expected and stays easy to debug, maintain, and extend. First, React components must return JSX. Whether you're working with a functional or class component, they need to return a representation of your UI in the form of JSX, a syntax that looks similar to HTML but is actually JavaScript. React uses this JSX to render components on the screen. Without returning JSX, a component has no way to display content. So, always ensure that your component has a return statement, and within that return, provide JSX or another component to display. Component names must start with an uppercase letter. This is a key React rule to distinguish between HTML tags and React components. React uses the lowercase letters to represent native HTML elements, like div or button. If you name a component with a lowercase letter, React will treat it as an HTML element rather than a component. So, always capitalize the first letter of your component name to avoid confusion and ensure correct rendering. React also mandates that components should be pure. A pure component is one whose output is determined solely by its input properties, props, and state, with no side effects or reliance on external values. This makes the component predictable and easier to test. In contrast, components that rely on external data sources or perform side effects inside the render method can cause bugs and make your app harder to debug. State should not be directly mutated. React state should always be treated as immutable. To change the state, use the setState method in class components or the useState hook in functional components. Directly mutating the state can cause React to lose track of changes and may lead to inconsistent rendering. By using setState or the useState hook, you give React a way to re-render the component when the state changes. Props are read-only. When you pass props to a component, they are immutable within that component. Props cannot be modified by the child component that receives them. This ensures a clear data flow and makes components easier to reason about. If you need to modify or change a prop, it's better to lift the state up to a parent component, where the data can be updated and passed down to the child component. Use hooks for managing state and side effects in functional components. With the introduction of hooks in React, developers no longer need to use class components to manage state or side effects. Hooks like useState, useEffect, and useContext allow you to write cleaner, more concise functional components. However, it's essential to follow the rules of hooks. Always call hooks at the top level of your component, never inside loops or conditionals, and ensure they are called in the same order on every render. Always clean up side effects. When using hooks like useEffect to handle side effects, make sure to clean up any subscriptions, timers, or event listeners when the component unmounts or when the effect is no longer needed. This helps prevent memory leaks and keeps your app's performance optimal. Finally, React components should be declarative. This means describing how the UI should look based on the current state or props, rather than imperatively telling the browser how to update the DOM. React is built on the idea of declarative rendering. When state or props change, React automatically updates the DOM to reflect the changes, which makes your code simpler, more predictable, and easier to manage. These fundamental rules are crucial for writing effective React code. They guide you in structuring your components, managing state and props, handling side effects, and ensuring that your app is both efficient and maintainable. By adhering to these rules, you will create React applications that are more reliable, easier to understand, and ultimately easier to work with over time. React Component Lifecycle. In React, the component lifecycle refers to the series of events that happen from the time a component is created until it is destroyed. Understanding the lifecycle of a component is crucial for managing state, side effects, and performance, especially as your application grows. React class components go through three primary phases: mounting, updating, and unmounting. In React 19.1 and the latest versions, lifecycle methods are primarily used in class components, but with the introduction of hooks, functional components also have ways to handle lifecycle events in a more declarative way. Let's take a look at each phase. The mounting phase is the process when a component is created and inserted into the DOM. During this phase, several lifecycle methods are called in sequence. Constructor. This method is called before anything else when a component is initialized. It's typically used to set the initial state or bind event handlers. It's a place where you can configure how the component will behave when it first mounts. Get derived state from props. This static method is called before each render, both on initial mount and on updates. It allows you to update the state based on changes in the props passed to the component. It's rarely used but can be helpful in specific cases where state depends on props. Render. This is the most important method in the mounting phase. It's where the JSX or React elements that define your component's UI are returned. This method should be pure and not contain side effects. Component did mount. This method is called after the component has been rendered to the DOM. It's often used for tasks like fetching data from an API or setting up subscriptions or timers, as it runs after the component's first render. Once a component has mounted, it enters the updating phase, which occurs whenever there is a change in state or props. During this phase, the following methods are invoked. Get derived state from props. This method is called before every render, not just the initial one, whenever the component's props change. It can be used to update the state in response to prop changes. Should component update, this method allows you to optimize performance by deciding whether the component should re-render or not. By default, every time the state or props change, the component re-renders. But if the new state or props don't affect the component's output, you can return false here to prevent unnecessary rendering. Render. As mentioned earlier, the render method is called each time a component updates. It will return the JSX that reflects the updated state or props. Get snapshot before update. This method is called right before the changes from the render method are committed to the DOM. It gives you the opportunity to capture information, such as scroll position, before the DOM is updated. Component did update. This method is invoked after the component's updates have been applied to the DOM. It's useful for handling side effects that need to happen after an update, such as network requests or manipulating the DOM based on changes in state or props. Finally, the unmounting phase occurs when a component is removed from the DOM. This phase involves a single lifecycle method. Component will unmount. This is called just before the component is destroyed. It's the perfect place to clean up resources, like canceling network requests, removing event listeners, or clearing timers, to avoid memory leaks. In addition to these lifecycle methods, functional components in React use hooks to manage their lifecycle. The most common hook for handling lifecycle events is useEffect. It replaces many of the class component lifecycle methods like component did mount, component did update, and component will unmount. You can use useEffect to handle side effects like data fetching, subscriptions, or manually manipulating the DOM. For example, if you want to perform an action when a component mounts or updates, you can use useEffect with an empty dependency array to run it only once, similar to component did mount. If you want to clean up resources, you can return a cleanup function from within useEffect, which acts like component will unmount.